The goal of this subproject was to design an efficient, strong wing for the BRZ rear wing project. The wing was redesigned with a change in the camber that allowed for an increase in aerodynamic downforce, yet maintaining a low aerodynamic drag force. The wing would be raised and active starting at 80 km per hour, and it would provide a downforce and rear smoothing of airflow up until 200 km an hour, at which point the wing would be stowed. I considered using a design in which the wing camber would change with reference to the down or potentially up force required, but this method seemed a little more complex and likely a project on its own. I decided against using an adjustable cambered wing for that reason. Using a Delta 3D printer, all 5 wing modules were printed using metallic aluminum PLA along with basic black PLA for the outer modules. Originally, I had planned to print the wing modules at a layer thickness of 0.05 mm at a honeycomb infill structure of 50%. However, the print time was over 24 hours for each wing module. So instead, I decided to print the modules at a layer thickness of 0.1 mm and at an infill rate of 25% with straight hatch pattern. This was to keep the print time down to an acceptable level. The modules were attached using 3 wooden spars running the length of the wing through holes printed in each module. Later, only 2 spars were used in the structure to simplify the system and increase structural integrity of the modules. At each end of the wing, a screw held the module tips from sliding off, whereas the middle modules were not directly secured to the spars. Sometimes the prints did not pan out as expected, which can be frustrating on prints ranging from 8 to 12 hours, as you can imagine. I found adjusting the extrusion width to the thickness of about 0.1 mm greater than the nozzle diameter increased the print quality and strength of the overall print. At the start of the project, I intended to use gear motors embedded within the wing structure to rotate the wing about its center of aerodynamic force. However, after some testing, I found that the embedded gear motors had sheared, causing failure to the entire motorized system. In the end, I reverted back to using stronger gear motors similar to the ones I used in the actuating supports. Once the wing was assembled, I also attached a safety cable. This cable would prevent the wing from flying off the car, potentially causing an accident, by securing the wing to the support structure on the trunk. Once the project is fully completed, I'm considering using a carbon fiber wrap over the wing surface to provide the aesthetic touch to the project as a whole. However, the project still has a vast amount of runway to cover before being active on the road.